Let us look at the next section, students. This section contains 8 questions. Each question has 4 options, out of which one or more than one option may be correct. Okay, so let's start with question number 29 now. When cyclohexa 2,4-dienone is treated with CHCl3 in presence of KOH, after acidic hydrolysis, it leads to the formation of a compound R with molar formula C7H6O. Okay, so students, if we talk about the given reaction, we have cyclohexa 2,4-dienone. Okay, so the ketone has to be by default given as number 1 in this case. Okay, so there is diene present at number 2 and number 4. Okay, so this is the structure of the cyclohexa 2,4-dienone. Okay, so we can have its reaction with CHCl3 in presence of KOH. So students, if we look very carefully, this compound can tautomerize to give us the phenoxide ion. Okay, so this is the Riemann-Tiemann reaction. Okay, so the examiner seems to be interested in the intermediates which are involved in the given reaction mechanism. Okay, now if we talk about the reaction mechanism, students, this KOH and CHCl3 will first interact with each other to lead to the formation of dichlorocarbene. Okay, so we're going to have the formation of CCl2, which is the dichlorocarbene. And now if we start with this given compound, so the alpha hydrogen will be extracted. This base is going to extract the alpha hydrogen from over here and leading to the generation of a carbon ion. So this carbon ion will now attack the dichlorocarbon, which is an electrophile. It has a vacant p orbital. Okay, so this is going to lead to the formation of this intermediate, students. Now there will be an intramolecular proton transfer from the cyclic carbon to the acyclic carbon, which is present outside. So this is going to lead to the generation of the carbon ion over here. Okay, so we're going to have CHCl2 negative. Now this carbon ion will undergo tautomerization, students. So there will be tautomerization happening, and then this will convert into the substituted phenoxide ion. Okay. Now students, there will be the attack of OH minus on this carbon. Okay, so this is going to lead to the formation of CHO over here, and then this is acidified to give us benzaldehyde. Okay, so this is the reaction mechanism in front of us, students. We have to look at the intermediates. So if we look very carefully at the options given to us, we can see that the intermediate mentioned in option A will be obtained. Now if we talk about the compound B, this compound will not be obtained as an intermediate in any step. If you talk about the compound given in option C now, this will also not be obtained. Okay, and if you talk about the last one which is given to us, so this is obtained, students. This is the one which is mentioned over here. This compound or this intermediate. So students, the intermediate given in option D is also correct. Okay, so students, for question number 29, we have to mark the correct answer as option A and option D. Let us look at question number 30 now, students. Consider the reaction of an alcohol with NaOCl in CH3COH at a temperature of 0 degrees C. Okay, so we have been given this reaction, students. So this is a secondary alcohol with the carbon being labeled over here. It is allowed to react with NaOCl. So students, this NaOCl is an oxidizing agent. It is going to convert this alcohol into a ketone. Students, the product which is formed is going to be cyclohexanone with the carbon atom label. Okay, so we have to identify the correct statements out of the given one. Okay, option A, it says that the oxidation state of labeled carbon atom remains same. This is not correct, students. The oxidation state of labeled carbon atom is not same. If we talk about option B now, hypochlorite ion attack through SN1 mechanism, so this is also not correct, students. If we talk about the third option now, so students, the carbon cannot get oxidized without the breaking of the CH bond or the C star H bond, to be more precise. If we talk about option D now, without ring opening, the formed product cannot be further oxidized. So this is correct, students. This is a ketone, and then it cannot be further oxidized if the ring is not opened. Okay, so students, for question number 30, we have to mark the correct answer as option C and option D. Let us look at the next question now. Question number 31. After the completion of the reaction 1 and 2, the organic compounds in the reaction mixture is are. So students, we have 1 mole of acetone. It is allowed to react with Br2, 2 mole in the basic medium, which is the aqueous NaOH, students. So this is going to give us bromoform. Okay, in the basic medium, the methyl ketones, they give us bromoform. So we're going to have the formation of CH3COO negative Na along with the formation of CHBr3, which is the bromoform now, students. If you talk about reaction 2 now, students, in reaction 2 we have acetone, which is allowed to react with Br2 in presence of CH3COH. So this is the acid catalyzed halogenation of the carbonyl compound, students, and we know that in the acid catalyzed halogenation, the product which is formed is this one. So the consecutive halogenation, they happen at different carbons. Okay. In the base catalyzed, the halogenation happened at the same carbon atom, whereas in the acid catalyzed, the halogenation happens at the different alpha carbons. Okay. So this is the major product formed in the reaction 2, students, and this is the major product which was formed in the reaction 1. Okay. So if we talk about the statements which are given to us, we have to mark the correct statements. So option A, it says reaction 1 will give the acetate ion along with bromoform. This is correct, students. If we talk about statement B now, reaction 1 and 2 will both give this compound as the final product. This is not correct, students. If we talk about option C now, reaction 1 will give this compound. This is also not correct. It is going to give the acetate ion. If you talk about option D now, reaction 2 will give the disubstituted compound. So this is correct, students. So out of these given statements, students, option A and option D are correct, and they have to be marked as the correct answer to this question. Let us look at question number 32 now. Identify the reaction which will finally produce an aromatic compound. Okay, so we have the reaction given in option A. So this imide, it is called an imide. It is allowed to react with LiLH4. So LiLH4 is going to remove the oxygen atoms from over here. So we're going to get the pyrrolidine. Okay, so this is not an aromatic compound, students. If we talk about compound B now, in the compound B, this diketo compound is allowed to react with ammonia and heated. Okay, students, if we talk about the reaction mechanism, this lone pairs over N will attack the carbonyl carbon, leading to the formation of hydroxylamine. Okay, so we're going to have the formation of NH2 and OH. Okay, now this lone pairs of nitrogen can attack at the adjacent carbonyl carbon as well. Okay, so this is going to give us a cyclic structure. Okay, and when this compound is heated, students, there will be dehydration. So there will be 2 water molecules which will be lost from the given structure. So H and OH, and then H and OH from here as well. So this is going to lead to the formation of a substituted pyrrole. So students, we can clearly see that this is an aromatic compound. So option B is correct. If we talk about option C now, in option C we have CH3Br reacting with KCN in presence of ETOH. Okay, so this is going to lead to the formation of CH3CN. Okay, this is now allowed to undergo hydrolysis. So this is going to give us CH3COH. Okay, so this is the compound T which was formed. T is allowed to react with red P and Br2. So this is the HVZ reaction. It will lead to alpha halogenation. So compound U is CH2Br COOH. Okay, now this compound U is allowed to react with NaOH and then it is hydrolyzed. Okay, so NaOH is going to convert this into the carboxylate anion, and then it is also going to cause substitution of this Br group. Okay, so we're going to have the formation of CH2COO negative and OH as an intermediate, and this on acidic hydrolysis is going to lead to the generation of acid. Okay, so if we talk about the compound V, the compound V is CH2OH COOH, and now students, when it is heated, so this is an alpha hydroxy acid. So we know that when the alpha hydroxy acid is heated, it is going to lead to the formation of a cyclic diester or the lactide. Okay, so we're going to get the formation of a cyclic diester as shown. Okay, so 6-membered ring is going to be formed over here. So this compound is also not aromatic, students. This is the major compound W which was obtained. Okay, now if we talk about the last reaction now, students, in the last reaction we have this compound reacting with the given reagent and in presence of NaOEt. So there are alpha hydrogens present in this compound, students. There will be carbon ion generated at both this position and they will both attack intramolecularly. Okay, so this will not happen as shown, it will happen stepwise, but then the final product is going to be obtained is this one. Then there will be OH present over here. Okay, so this compound will undergo dehydration to give us this compound. And now, students, if we talk about this structure, this bond will polarize in such a fashion, leading to the generation of an aromatic compound. Represented as such. Okay, so in this compound, both these given rings are aromatic. This is a 7-membered ring which also has 6 pi electrons in complete conjugation. Okay, students, in option D as well, there is the formation of an aromatic compound. So for question number 32, we have to mark the answer as option B and option D. Let us look at the next question now. Question number 33. Which of the following reaction correctly represent the major product? Okay. If you talk about option A, students, we have benzoic acid reacting with bromine in aqueous medium. So students, this is the deactivated benzene ring, and the deactivated benzene ring will not show the tribrominated product. There will be monobromination happening at the meta position. Okay. Let us look at option B now. So in option B, we have this structure. It is allowed to undergo reaction with the nitrating mixture. So students, this is not correct. In the presence of the nitrating mixture, this aniline or the amine, it will get protonated to give us the ammonium ion, and then this will act as a deactivating group, and then it is generally meta-directing. So the orientation of the attack will be according to this oxygen atom, which has a lone pair of electrons. So the substitution is going to happen at this position and not at the position where it is represented in the major product. So option B is also not correct. If you talk about option C now, in option C we have this alcohol. It is allowed to react with HCl. So students, this HCl is going to protonate the alcohol and convert it into the oxonium ion, and this is going to leave. Okay, so we're going to have the generation of this carbocation. Now students, this carbocation will rearrange to form a tertiary carbocation. So there will be rearrangement happening, and this carbocation is going to get formed. So the carbocation is just present outside the 4-membered ring. So if there is a possibility of ring expansion from 4 to 5, it is going to happen as there is a release of angle strain. Okay, so this group will shift. There will be ring expansion happening. Okay, so this is going to lead to the formation of this carbocation finally. And now students, the chlorine will add at the carbocation, leading to the formation of this product. Okay, so if you look at the answer which is given to us, this is a correct reaction, students. The reaction given in option C is correct. If you talk about the last reaction now, we have PHMgBr reacting with 2 moles of PHCHO. Okay, so we have benzaldehyde reacting with pH negative. Students, the pH negative is going to attack the carbonyl carbon. It is going to lead to the formation of the alkoxide. Okay, and now this negative charge over oxygen will come back and make this hydride leave. So this hydride ion is going to attack another PHCHO molecule and lead to the formation of the benzyl alcohol. Okay, so finally students, benzyl alcohol is obtained, and then if we talk about this compound, this will convert into the benzophenone. Okay, so students, we have the formation of benzophenone and we have the formation of benzyl alcohol. So if you look at the products which are given to us, students, we can clearly see that this reaction is also correctly represented. Okay, so for question number 33, we have to mark the answer as option C and option D. Let us look at the next question now. Question number 34. Tranquilizers are a class of compounds used for treatment of stress and mild or even severe mental disease. Equinil is an example of tranquilizer drug and is used in controlling depression and hypertension. Identify the statement which is incorrect about Equinil. Okay. So students, if we talk about this Equinil, we have the structure of Equinil as this. Okay. So this is the structure of Equinil, students. Okay. Now if you look at the statements which are given to us, we have to identify the statement which is incorrect. Okay. So option A, it says it is optically inactive. So we can see that it is indeed optically inactive. There is no chiral center present. So this is the correct statement. Option B, it says there are two ether linkages. This is not correct, students. There are no ether present. Okay. If you talk about statement C now, it has two NH2COO groups. So this is correct, students. We have the indicated groups over here. So there are two groups present. So statement given in option C is also correct. If you talk about the last option, it has two geometrical isomers. So this is not correct, students. The given compound, it does not show geometrical isomerism. Okay. So out of the given statement, statement B and statement D are incorrect. And so we have to mark the answer to this question as option B and option D. Let us look at the next question now. Let us look at question number 35 now, students. In the given molecule, Claisen rearrangement occurs. So we've been given this reaction. And the examiner is interested in the compound which is not obtained as the product of the above reaction. Okay. So if we try and figure out the product which will be formed, students. So we have the benzene ring. Okay. And then we have the alkene group. Okay. So we've just rearranged the given compound. The bonds have been rearranged in a more suitable fashion. Okay. Now students, if we talk about the Claisen rearrangement, it is a pericyclic mechanism. So this bond will shift over here and this bond will shift over here. Okay. So this is going to lead to the formation of okay. So this is the product which is going to be formed, and now this will tautomerize to form the aromatic compound. Okay, so this is the major product which is obtained in the given Claisen rearrangement reaction, students. And if you look at the options which are given to us, students, if you look at option A, this given set of compounds will not be formed. If you look at option B, this compound is also not formed. If you talk about option C now, so option C has one carbon extra, additional carbon atom is occurring outside the benzene ring. So this is also not correct. And if you look at the last one, the last compound is also not correctly represented. Okay, so none of these given products will be obtained as the major product in the above reaction. So students, all of this have to be marked as the correct answer to question number 35. Let us look at question number 36 now. Question number 36. Consider the following reaction sequence. So we have been given this reaction in which there is Hofmann-bromamide degradation reaction happening. Okay, so if you talk about this amide is going to lose the CO group in presence of Br2NaOH. So we're going to have the formation of this compound in the beginning, and now there will be intramolecular attack of the amine group. So this is going to lead to the formation of this compound. Okay, so if we talk about the options given to us, the examiner seems to be interested in the correct statements. Okay, so option A, it says product has an amine group. This is not correct, students. It has an amide group. There is no amine group present. Okay. If you talk about option B now, if product P is treated with LiLH4, it will lead to the formation of this compound. So this is correct, students. When this is allowed to react with LiAlH4, this is going to lead to the formation of the given amine. Okay. So statement B is correct. If you talk about statement C now, it has a CONH linkage. So it has an amide linkage, students. So this is also correct. If you talk about option D now, its molar formula is C8H10NO. So this is not correct, students. There cannot be a compound having this formula, as it gives a fractional degree of unsaturation. Okay, so this is not correct. So students, for question number 36, we have to mark the answer as option B and option C. Let's look at the next section now, students.